Definition: a lymph node or lymph gland is an oval-shaped organ of the immune system, distributed widely throughout the body, including the armpit.
Lymphoid organs, such as lymph nodes, have a specialized architecture containing separate T and B cell regions. The architecture of the lymph node begins to be established when stromal cells secrete the chemokine SLC, which attracts dendritic cells to the developing lymph node. The dendritic cells also secrete SLC and a second chemokine, MIP3 beta. This combination of chemokines attracts both T and B cells into the lymph node. The separate B cell areas are established.
Clinical significance: they become inflamed or enlarged in various conditions, which may range from trivial such as throat infection to life-threatening such as cancers. In the latter, the condition of lymph node is so significant that it is used for function. The lymph node fluid inside the lymph nodes contains lymphocytes, a type of white blood cells, which continuously recirculates through the lymph nodes and the bloodstream. Molecules found on bacterial cells, walls, or chemical substances secreted from bacteria, called antigens, may be taken off by dedicated antigen-presenting cells such as dendritic cells into the lymph system, and then into lymph nodes. Structure: the lymph node is surrounded by a fibrous capsule, and inside the lymph node the fibrous capsule extends to form trabecula. The substance of the lymph node is divided into other cortex and the inner medulla, surrounded.
These are called villi. They're found in the small intestine. They're part of the adaptation to small intestine to increase its surface area. You can see capillaries here for absorbing many of the nutrients. Over here, though, is a special lymphatic capillary called a lacteal, and that's going to collect lipids and fat-soluble vitamins. You can also see it on this model here, shown in green. Also on this model, you see a lymphatic nodule, part of what we call pyropatches. You find a lot of them, especially in the last part of the small intestine, called the ileum. This is a model of a lymph node. The outer portion, called the cortex, is where we find especially a lot of T cells, cortex T cells. This is the medulla, starting with an M. That's where you find a lot of macrophages. The germinal centers here are where you find a lot of B cells. Notice we have lots of trabeculae. We also have more afferent vessels entering, which you can't see here, than efferent vessels leaving. That means the lymph is going to slow down as it goes through the lymph node, and it gives plenty of time for the lymph node to act on the material going through the lymph. Also, the reticular fibers help trap pathogens and other debris coming in.
Structure. The number and composition of follicles can change, especially when changed by an antigen, when they develop an germinal center. A lymph sinus is a channel within the lymph node lined by the endothelial cells along with fibroblastic reticular cells and allows a smooth flow or lymph through them. Thus, the subcapsular sinus is a sinus immediately deep to the capsule, and its endothelium is continuous with that of the afferent lymph. Cortex. In the cortex, the subcapsular sinus drains to the trabecular sinuses and then the lymph flows into the medullary sinuses. The outer cortex consists mainly of the B cells arranged as follicles, which may develop a germinal center when changed with an antigen, and the deeper cortex mainly consisting of the T cells. There is a zone known as the subcortical zone where T cells, or cells that are mainly red, mainly interact with dendritic cells and where the reticular network is dense. The predominant site within the lymph nodes which contain T cells and accessory cells is also known as paracortex reticular network. Medulla. There are two named structures in the medulla. The medullary cords are cords of lymphatic tissue and include plasma cells, macrophages, and B cells. The medullary sinuses or sinusoids are vessel-like spaces separating the medullary cords. Lymph flows into the medullary sinuses from cortical sinuses and into afferent lymphatic vessels. Medullary sinuses contain astrocytes, immobile macrophages, and reticular cells. The medulla contains large blood vessels, sinuses, and medullary cords that contain plasma cells secreting antibody. Shape and size. Human lymph nodes are being shaped and ranged in size from a few millimeters to about 1–2 centimeters long. They may become enlarged due to a tumor or infection, or inflamed due to leukemia. Lymphocytes, types of white blood cells, are located within honeycomb structures of the lymph nodes. Lymph nodes are enlarged when the body is infected, primarily because there is an elevated rate of trafficking of lymphocytes into the node from the blood, exceeding the rate or outflow from the node, and secondary as a result of the activation and proliferation on antigen-specific T and B cells.
The lymphatic system is a complex network of thin vessels, valves, ducts, nodes, and organs. It helps to protect and maintain the fluid environment of the body by producing, filtering, and conveying lymph, and by producing various blood cells. Lymph nodes play an important part in the body's defense against infection. The most common cause of swollen lymph nodes is infection, which might occur even if the infection is trivial or not. Here's an enlargement of a lymph node. To better understand its function, let's take a look at a cut section. Afferent means towards. Afferent lymph vessels bring unfiltered fluids into the lymph node to be filtered. Efferent means away from. Efferent vessels carry clean fluids away from the lymph node and to the cardiovascular system, where it helps form the plasma in the blood. Overall, it works like a biological filtering system. When the body is invaded by foreign organisms, the painful swelling sometimes felt in the neck, armpits, groin, or tonsils comes from the microorganisms being trapped inside collections of lymph cells or nodes. Eventually, these organisms are destroyed and eliminated by cells that line the walls of the lymph nodes. Then the swelling and pain subside.
Lymphatic circulation. Lymph circulates to the lymph node via afferent lymphatic vessels and drains into the node just beneath the capsula in the space called the subcapsular sinus. The subcapsular sinus drains into trabecular sinuses and finally into medullary sinuses. The sinus space is crisscrossed by the pseudopods of macrophages, which act to trap foreign particles and filter the lymph. The medullary sinuses converge at the ileum, and lymph then leaves the lymph node via the efferent lymphatic vessels towards either a more central lymph node or ultimately, from draining into a central venous subclave blood vessel, most via the postcapillary venulus, and cross its wall by the process of diaperesis.
The lymphatic system is a network of vessels lying adjacent to the capillaries. It aids the circulatory system in transporting fluids and is a vital part of the immune system. In and around the cells of the body, extracellular fluid collects waste products and carries nutrients and oxygen to the cells. Some of the fluid travels through the capillaries. Some, especially proteins too large to enter the capillary membranes, circulates through the lymphatic vessels. The lymphatic vessels flow through several lymph nodes. These lymph nodes contain concentrations of white blood cells, which kill bacteria and other harmful agents trapped in the nodes. The tissue fluid returns to the circulatory system through the large vein.
The B cells migrate to the nodular cortex and medulla. The T cells migrate to the deep cortex, paracortex.
The lymphatic system